Hello students, welcome to the Master School Foundation program. Today we would like to discuss about that refraction of the light through the curved surfaces and the problems based on the refraction of the light through the curved surface. It's very clear. So we would like to discuss about this one. Yeah, let's have a look. So problems based on the refraction of light through curved refracting surface. All right, it's very clear. Let's go further. Just you have to see. This is going to be having that single convex refracting surface. Okay, it's very clear. You would like to go for that. CB the center. It's very clear, and you will get that radius of curvature, and object is going to be point object which is at O. We are going to identify this one. This is going to be the object. It's very clear. Now you have to get this one. Yeah, if we are going to identify that. Yes, let's have the look into that matter. We would like to go for this one. So in this case, we would like to apply the formula identifying that position of object, and also we would like to take the parameters that are radius of curvature and the refractive index of that medium, denser medium. So this is the case we would like to confirm the light rays are entered from the rarer medium to denser medium. All right, it's very clear. We would like to go for this one. Okay, let's have the look. Right, here from the figure we would like to get the data. You know very well about that. This is going to be mu 2 by V minus mu 1 by U is equal to mu 2 minus mu 1 by R. This is the formula which is going to be related to different parameters. So you can easily find out that, yeah, you will get the U, V and also the nature of image. You can decide that. It's very clear. You would like to go for that. Suppose that we have seen this is going to be taken, the light rays which are originated here and they are going to be incidented very clear. It further proceeded and it is going to meet at this point, right? You have to confirm this one. You would like to talk about that. So here the refracted light ray which cuts the principal axis, this is going to be the principal axis, very clear, right? This is going to be the object. Yeah, the light ray which is refracted at the single curved refracting surface and it will further proceed to that in forward direction, let's assume. So it will cut the principal axis at this point, it will forms the image. That image is going to be real. It's very clear. Okay. If it is going to be appear to meet at this point, okay, right, it is in the correct place. If it is going to be here, the image is going to be here, then it is known as that virtual image. All right, that's what we would like to guess that. In this case, we would like to go for that estimation whether the nature of image is going to be real or virtual. Where does it will form? Okay, let's go for that. We would like to go for this one. Right, from the given data you can write down, right, that is, let's assume this is going to be mu 2 This is going to be mu 1, right. Yeah, refractive index of rarer medium, that is going to be mu 1, that is equal to 1. Yeah, refractive index of denser medium, you would like to confirm, that is mu 2 given value, that is equal to 1.5. all right, it's very clear. Here it's going to be the center. Yes, you have to confirm that this is going to be the R. Easily you will find out that, right. Now regarding to that radius of curvature, R is equal to 30 centimeter, very clear. Now object distance, u is equal to minus 15 centimeter, it's very clear. You would like to go for that. Okay, it's clear. You would like to get that image distance. Is equal to question mark. You have to get this. So you have to locate that where the image has been formed. So what we are having the data, you can confirm, it's very clear. Now if you are going to use that all these parameters, you can solve the problem. It's very easy for you. Right. This is going to be the pole. From that you have to get that this object, presence of object is going to be negative. Just you have to get. Okay, let's have the look into that matter. Everyone has to identify that diagram and you can solve the problem. Easily you will get that. So the problem solvation is in the matter of the calculations, you can go for that, what we are having. Right. Okay. We would like to know for that, that is related formula. That is you have to take that mu 2 by V minus mu 1 by U is equal to mu 2 minus mu 1 by R. It's very clear. We would like to go for that. Okay. Now we would like to go for that. This is the right. This is the formula. So already you have that. That is 1.5 by V minus 1 by minus 15 centimeter is equal to 1.5 minus 1 by 30 centimeter inverse. Centimeter inverse we have to consider. We have to consider centimeter inverse. Very clear, we would like to go for that. Okay, if it is very easy to solve the problem having the simplification, while you are going to have the calculation, you should follow that number of steps to get that correct answer. You should have that 1 by 15 is equal to 0.5 by 30. Yes, you can go for that 1.5 by V is equal to 0.5 by 30 minus 1 by 15. It's very clear. You can go for that LCM and solve the problem easily, you will get that. Yes, you can go for that. 1.5 by V is equal to you will get that 30 whole upon that is 0.5 minus 2. So 1.5 by V is equal to minus 1.5 by 30, right, up to this extent. That implies you can have the look, that is 1 by V is equal to minus 1.5 by 1.5 into 30. You can cancel the term, all right. So you are having that 1 by V is equal to minus 1 by 30. All right. Finally, can you guess that what is the value? It's going to be minus 30. V is equal to. Can you guess that nature of that image, which is going to be the real or virtual? And either in this side, it is in the correct place or not, you have to decide it. This is the point object. So that the image has been formed at minus 30 centimeter, which is going to be the virtual image, no doubt at all. All right. Let's go for that. So V is equal to minus 30. It's going to be virtual. All right. Please have the look into that matter. Everyone has to identify that, right? You can go for that nature, which is going to be the virtual. It has been formed at somewhere else. This is going to be that virtual, right? You have to set this one. This is the case we have confirmed. I is going to be the virtual image. All right. Okay. So let us go for that another problem. All of you have the look into that matter. Okay. Yeah. Let us take that. It's very clear. In this case also we would like to go for that. Locate that image formed by the refraction in the situation shown in the figure, as the point C is going to be the center of curvature. It's very clear. You would like to go for that. Yeah, from the figure it was confirmed that you would like to go for this one. This is going to be the R, all right. Okay. This is going to be that U. Yes, you have to confirm. Very clear. That is, you have to take this one, right. It's going to be 25 centimeters. Okay. Yeah, this is going to be U2. This is going to be U1, refractive index of that rarer medium. This is going to be the denser medium. Okay, the light rays are, what is the case? The light rays are enter from rarer to denser medium. All right, it's very clear. So, where does it actually meets at this point? Okay, yeah, right. Let's have the look into that matter. You would like to get that U is equal to minus 25 centimeter. All right, it's very clear. R is equal to 20 centimeter. All right, you will get this one. And mu1 is equal to 1, mu2 is equal to 1.5. It's going to be the glass, just they have given already. But you have to identify that V is equal to question mark. You have to take this one. Okay. Now, by using the formula, we will solve the problem. It's going to be mu2 by V minus mu1 by U is equal to. That's very clear. Mu2 minus mu1 by R. We would like to apply this formula. After getting all the values from the given diagram, just you can substitute and proceed for the calculations, and you can decide that by getting that image distance, the nature of image is going to be the real or virtual. Let's see. Right, you will get that. Yeah, 1.5 by V minus 1 by minus 25, that is equal to, you can take that 1.5 minus 1 by what you are getting that 20. All right, it's very clear. You would like to go for this one, right? Therefore 1.5 by V plus 1 by 25 is equal to 0.5 by 20. It's very clear. All right, now we would like to go for that. Yeah, 1.5 by V is equal to 0.5 by 20 minus 1 by 25. Yes, you have to take this one. This is very clear. If you are going to get that 1.5 by V, after getting that calculation, you have to get that, consider that LCM. It's going to be 5 fourths and 5 5s. Just you have to get this 20, 25. Yeah. Just you will get that. That's going to be 100. Okay, you will get that 5 into 0.5 minus 1 into 4. It's very clear. All right, now you can easily solve the problem. After getting that, you can solve this one, right? So that is, you can get that, yeah, you are writing that 1.5 by V is equal to, yeah, you will get that 2.5 by 2.5 minus 4 by 100. So easily you will solve the problem. That is 1.5 by V is equal to minus 1.5 by 100. If you are going to get the cancellations, please have the look. It's very clear. Now what we are having that value, you have to see that 1 by V is equal to minus 1 by 100. This is the final what we have to get this one. Please have the look. So easily you will confirm that V is equal to minus 100. That's very clear. 100 centimeters just you have to get. So what can you say about this one? It's going to be at in this one. So the nature of image is going to be the virtual. It's very clear. It is going to be in the right place. If that image has been formed, which is going to be further proceeded by that ray which meets that principal axis at the right place, that is going to be the real. Here you have to confirm, right? Let's have the look into that matter. Okay, yeah, you have to just have the look. You have to use this. It's very clear. Yeah, okay. Here we are considering that 1 by V is equal to minus 1 by 100. So V is equal to minus 100. Very clear. You are all going to get this one. All right. So you have to get that first one is the correct. Then you can decide that the image is going to be the virtual. No issue at all. Yes. Have the look into that matter in what way does we are having the solvation. All right. Okay, let's go for that. Another problem. Yes, you have to see this one. This is very clear. So we would like to go for that. This is going to be the point object. Let's consider here. It's very clear. We would like to find the position of image. Yes, you have to confirm. Find the position of image. What is the nature of image? That is very, very important. You have to consider that one. Yeah, you have to get this one. Yes, everyone has to identify that, right? While looking into that matter, you have to confirm this is going to be that air. This is the air medium. This is going to be the glass medium. So mu1 is equal to 1. This is going to be mu2. This is going to be 1.5. All right. Okay, this is the u. If it is going to be the point object, this is going to be the u, this is going to be the pole, this is going to be the r. Let's assume, right, r. Okay, yeah, we have to confirm from the given diagram. Just you have to take this one. U is equal to minus 20 centimeter. This is going to be the point object. It's very clear. We have to confirm. This is going to be O. Yeah, at that place we have to consider. Right, okay, R is equal to 20 centimeter. All right, very clear. We have to consider that U1 refractive index of the rarer medium, that is going to be 1, that is going to U2 1.5. Okay, all right. You have to get this V, that is going to be the question mark. You have to solve the problem. Right. How you can solve the problem? Just you have to consider that equation, that is, you have to take that U2 by V minus U1 by U is equal to mu2 minus mu1 by R. So, have the substitution, that is 1.5 by V minus 1 by, what about that one? That is going to be minus 20. So, all upon centimeter inverse, that is equal to, you have to write down, that is going to be 1.5 minus 1 whole upon that 20. Okay, yeah, this is going to be get 1.5 by V plus 1 by 20 is equal to 0.5 by 20. All right. So, you will get that if you are going to have that sign, you have to consider that fine, this is going to be the object. We have to confirm where the image is going to be formed. Right, we have to take that 0.5 by 20 minus 1 by 20. Okay, after that, that implies 1.5 by V is equal to 20 by, just you have to minus 0.5. You have to consider this one. All right. Yeah, you have to take this one. Yes. So, you have to solve this problem, that is 1.5 by V is equal to minus yes, 1 by V is equal to minus 0.5 by 20 into 1.5, right? It is going to be 3 by 2, 30, yeah. 1 by V is equal to minus 0.5 by 30, right? So, 1 by V is equal to minus 0.5 into 10 by 300. Yes, you can solve this problem, that is going to be, yeah, finally you will got that, all right. Yes, you have to solve this problem and get the answer, it is very easy for you. Have the look into that calculation part and yeah, that is 1 by V is equal to minus 5 by 300, that is very clear. Therefore, 1 by V is equal to minus 1 by 60, yeah, That implies V is equal to minus 60 centimeter. All right, you may have that image formation here, it's very clear. At somewhere else you will get that image. This is going to be having that image, that is going to be the virtual. All right, just have the look. Everyone has to identify that. Yeah, you are all going to identify that. You need to solve the problem. That is going to be getting that at minus 60 centimeter, that image is going to be formed. So this is the position. Let us assume this is the position. In this way, just we have to approach for that calculation of image distance. All right. Okay, let's go for that another problem. In this problem, just we have seen that position of image is going to be here and R is going to be here. This is going to be the single convex refracting surface. It's going to be here. We would like to go for that. We have to confirm that is going to be R is negative. Let's see that the possibilities in another problem. Okay, you are all going to identify that the position of image and the nature. It's very clear at minus 60. Just you have to take this one. So yeah, this is the correct one, right? Okay, we would like to go for that. You have to look into that matter and solve this one. In this way we can solve any problem whatever they have given. Sometimes you may calculate that refractive index and that R value also. Okay, let's go for that another problem. Right. Okay. Yes, everyone has to identify this one. Okay, this is the single concave refracting surface. Okay, find the position of the image and what is the nature of image. It's very clear. From that you can confirm this is going to be that air medium. All right. Yeah, it's mu1 is equal to 1, and yes, you have to take this one. It's very clear. Yeah, this is going to be mu2. All right. Okay, radius of curvature, it's going to be that R value. R is equal to minus 20 centimeter. All right, and U is equal to, this is going to be the point object. Let's assume U is equal to minus 20 centimeter. Very clear. Now you are going to get that position of image, where does it has been formed. Okay, let's have the look into that matter. Everyone has to identify that, right? And mu1 is equal to 1 and mu2 is equal to 1.5. All right, it has given that's going to be 1.5. Easily you will find out that. Yeah, this is going to be the object. Very clear. You have to get that image. By applying that equation, you can get that. While you are going to take the sign convention, this is the single concave refracting surface. We have to confirm its R is going to be the negative, that's going to be minus 20 centimeter. Object distance is minus 20 centimeter. Okay, let's have the formula and have the substitution. That is very clear. Therefore, U2 by V, and yeah, we would like to substitution and R. This is the case, we would like to go for that. Therefore, that is 1.5 by V minus 1 by minus 20 is equal to, yes, you have to get that 1.5 minus 1 by, what about R? That's going to be minus 20 centimeter. It's very clear. Now you can have that further calculations. Okay, that's very clear. So 1.5 by V plus 1 by 20 is equal to 0.5 by minus 20. All right, it's very clear. He would like to go for that. Yeah, that is 1.5 by V plus 1 by 20 is equal to minus 0.5 by 20. So 1.5 by V is equal to minus 0.5 by 20 minus 1 by 20. Okay, it's very clear. You would like to get this one, that is yes, you can write here 1.5 by V is equal to minus 1.5 by 20. Just you have to get the cancellation, it's very clear, it's going to be minus 1. 1 by V is equal to minus 1 by 20, V is equal to minus 20 centimeter. Let's have the look. Okay, it's very clear. So if you are going to confirm this is the correct one, right, you can decide that yeah, and it's going to be virtual, all right, it's very clear. You would like to confirm that it is going to be that virtual image which has been formed at minus 20 centimeter. So we have chosen that it's going to be virtual, all right. Please have the look and note down. Okay, let's go for another problem. Everyone has to identify that and get this one. It's easy. Let's have that another model problem which are different from these problems. Okay, right. Let's have the look. We would like to go for this one. Yeah, it is time to have the look into that matter. What we are going to see that. Right. Okay. A beam of light strikes the glass sphere. This is going to be the sphere, glass sphere, all right. This is the glass sphere, all right. Okay, you can go for that. Now, yes, you can identify that this is the pole, all right, P, and what they have given that object distance, this is going to be the object, and you have to find out that position of image. Okay, so once if you are going to identify the diagram, just the light rays are going to be incidented, yeah, they are going to be converged at this point O, all right. You will take that this is going to be converging point, this is going to be the O, all right. Now it's very clear, the converging rays are going to be appeared at this point. Okay, it's very clear. The refracted light rays forms the image. Actually, these are the incident light rays which are going to be refracted and they will form the image where the refracted light rays meets the principal axis. That is very clear. You would like to go for that. A beam of light strikes a glass sphere of diameter, what they have given, this is the diameter, very clear, all right. Okay, from that you will get that this is the diameter, all right, converging towards a point, converges towards the point. Okay, let's assume this is very clear, all right. You will get that, okay, behind the pole of a spherical. Find the position of image. Okay, from the given data, just you have to find out the position of image. It's very clear. And just you have to use this one, right? Okay, right. You will get that diameter. You will get that diameter is equal to 0.15 meter. So radius, that is R, is equal to 0.15 by 2 meter, that is 0.15 Yeah, you would like to get this one, it's very clear, you should keep it. Yeah, now you will get that u is equal to object distance, that is going to be 0.3 meter. All right, it's very clear. Right, okay. Now image distance, that is going to be the question mark. Okay, it's very clear. We would like to talk about that nature of image, which is going to be the real, where the refracted light ray cuts the principal axis at the right place. Okay, it's very clear. We would like to go for that. And also you have to get, u1 is equal to 1, u2 refractive index of that rarer medium, that's going to be 1.5. Very clear. We would like to go for that formula. What we have to get, that is going to be mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. Very clear. We would like to go for that. Yeah, we will use the limited space. Okay, all right. This is very clear. We would like to go for that. We will use up to this extent. That is, that is mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. It's very clear. We would like to substitute this one. Yeah, we would like to go for this one. Right, v is equal to question mark, that is going to be u, that is going to be v is equal to question mark. Let's have the look into that matter. Yes, everyone has to identify that. Yeah, we would like to go for that. Yes, you have to get the substitution, that is yes, you have to substitute all the values and you will get that image, position of image, right? That is 1.5 by v minus, what about 1 by, what is that mu value? It's going to be 0.3 meter. Yeah, so we are all going to take that, that is equal to, yes, you have to get that 0.5 by, what is r value? It's going to be 0.075. All right, it's very clear. Let's have to remove that. Very clear. We would like to go for that. Okay, if you are going to get this one, 1.5 by v is equal to 0.5, 0.075 plus 1 by 0.3. Yes, right. We would like to go for that substitution also. Yeah, we would like to go for this one and have the substitution. We can easily solve this problem. That is very clear. So, after finding all that, we would like to go for that. We would like to have that v is equal to 1 point, just you have to take this one. Yeah, you may get that. Yes, it's going to be that 0.15 meter from the pole, which is going to be the real. It's very clear. In this way, we will solve the problem. Yeah, you will get that 1.5 by V is equal to 5 by 0.75 plus 1 by 0.3. 0. Yes, you will get that 1.5 by V is equal to 0.3, it's going to be 2 plus it's going to be 1. So 1.5 by V is equal to 3 by 0.3. Now you will solve this problem 0.1. So V is equal to 0.1 into 1.5. Yes, 0.015 meter. It's very clear. Yeah, in this way we will solve the problem. Okay students, we would like to discuss the more problems in the coming classes also. Thank you very much. Have a nice day.